All right, number one. Julia is 4 years older than twice Kelly's age. The product of their ages is 96. Write an equation and solve to determine each girl's age. Okay. So whenever I'm doing problems like this, I always want to define my variables first. So I'm going to let X equal Kelly's age because they give me Julia's age in terms of Kelly's age. So then I'm going to write out Julia's age as 4 plus 2x. All right, cool. So now it says the product of their ages, product is the multiplication, is equal to 96. So I've got x times 4 plus 2x should give me 96. It says we need to write an equation and solve to determine each girl's age. So I'm going to distribute the x to each piece in the parentheses. And then I'm going to move the x over. Oh, wait. I want to move the 96 over. That's easier. I'll just do that. Minus 96, minus 96. I get 4x, 2x squared minus 96 equals 0. All right, cool. So what I'm going to do now is look for a GCF. Why am I looking for a GCF? Because there's a leading coefficient in front of the x squared. So I'm going to pull out a 2 from every term. And then that 2 is going to go outside the parentheses. And then I have 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. Negative 96 divided by 2 is going to be 48. And then now I'm going to factor. And I'm going to set each thing equal to 0 to get my solutions. 2 equals 0, throw it out. That makes no sense. I'm going to make everything a little smaller because I can't quite see everything, okay? So then now I've got x minus 6 equals 0. I'm going to add a 6 on both sides. X equals 6. So my two options for answers here are x equals 6 and x equals negative 8. I'm talking about ages of people. Which one am I going to accept and which one am I going to reject? G, negative years old doesn't make any sense at all. Goodbye. I'm going to take x equals 6. And I'm trying to find the age of each girl. So I have x equals 6. That's going to be Kelly's age. And then I have to find Julia's age in terms of Kelly's age. So that's going to be 4 plus 2 times 6. That's going to be 16. So Julia is 16. Kelly is 6. Hooray for them. Number 2. Pick the best method to solve algebraically. All right. I got a leading coefficient, and I cannot pull him out of every term. Quadratic formula. I don't even need to talk about it. Don't even think about it. There it is. Number 3. Solve algebraically. Round to the nearest hundredth. Well, I just told you to use the quadratic formula, so let's do it. A is 3. B is negative 2. C is negative 6. Let's calculate the discriminant. Okay, B is negative 2. A is 3. C is negative 6. The discriminant is going to be 76. So now I'm going to plug that into the quadratic formula. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to copy everything with nem. I don't know what I was trying to say. Empty parentheses. All right, B is negative 2. The discriminant is 76. And A is 3. I'm going to type the following into my calculator. And I'll get x equals, this should be 1.79. And negative 1.12. Hooray for us. Hooray for school. Simplify the radical. The square root of 405. I'm going to look for the largest perfect square that is a factor of 405. I gave you 405 on purpose. It's a number that we never work with. I wanted you to use the trick in the calculator to practice. So I do 405 divided by x, control T. Now I'm looking for the factor pair that contains a perfect square, and preferably a big one. A big one! 5 and the square root of 81. Whoa, excuse me. So I've got the square root of 81, the square root of 5. When I take the square root of 81, I put a plus or minus 9. We're at 5. Simplify the radical, the square root of 363. I did the exact same thing again. I gave you a scuzzy number so you could figure it out. 363 divided by x, control T. Look for that perfect square. There it is, 3 and 121. When I take the square root of 121, I put a plus or minus, and I get 11. My answer is 11 square root of 3. Thank you.